Okay guys, welcome back. In this video we'll continue looking at working with slope as a rate of change. Okay, so graphs tell us visually how one variable or thing changes compared to another variable or thing. Okay, so it tells us how one thing changes compared to another thing. Okay, just a little bit of lingo here. Dependent variable is a variable that relies on the other variable. Our dependent variable is always on the y-axis. Okay, and our independent variable, this thing happens no matter what. It's usually time. It's usually time, and that always goes on the x-axis. Okay, so looking at a couple examples here, this is an example that we can all relate to. There we have Willard who works excuse me, as an electrician's assistant and earns $12.50 per hour. Okay, what is the dependent variable? Well, dependent variable will be his income. His income is going to depend on how long or how many hours he works. Okay, write an equation that shows the relationship between hours worked and income. Well, his income is going to be however much he makes, or his rate times his hours. Okay, and if we shorten that, you can put I is equal to 12.50 times H for hours. Okay. So if we wanted to graph this, we could show this as, okay, well, after 1 hour. So I've filled in the axes for this graph, just showing here our y-axis or our income is going to go up $25 increments every 2 squares. So every 1 square is $12.50. We don't have to put $12.50 each time, and this one would be $37.50. We don't have to put all that in there. We can, as I've done here, just put 25, 50, 75, 100, space it out, and makes it a little bit easier to read. So, and same on the x-axis, we put the number of hours worked on the x-axis, and I just labeled the 246, knowing that each individual or in-between line is going to be 1 hour. Okay, so if we were to graph this equation, this would be at 1 hour. At 1 hour, he will have made $12.50. 2 hours, he will have made another $12.50, or a total of $25. 3 hours, $37.50, and so on and so on. Okay, so in this, so let's see if I can draw any straight line. This thing will go on forever. Okay, and you know, we can put some other points in here. If he works for 10 hours, then he's going to make $125. Okay, and we can pick off interesting or useful stuff from graphs. Our next chapter is going to look extensively at graphs, and we'll get a much better idea of different types of graphs and what to look for in them. Okay, the slope of this graph. The slope of this graph is going to be the rise over the run. So if you look at even between like our 0 point here and the first hour, our rise is going to be $12.50 and our run is going to be 1 hour. So the slope is $12.50, and what does it represent? Well, it represents his hourly wage. His hourly wage. Okay. So how much does Sir Willard make in 5 hours? We'd have to go to our graph and just say, okay, well, at 5 hours, we can go up to our graph and find that point. The income for that point is going to be where our arrow is, or 62.50. Another way we can do that is by looking at, hey, our income is going to be 12.50 times our number of hours, so in 5 hours. And if we plug this into our calculator, we'll end up with a value of 62.50. Okay, so on the back side, we have example number 2. Reg timed himself jogging on a race course. He passed the 300-meter point 1.5 minutes after starting, and the 600-meter point after 2.8 minutes. So I've recorded that info down here just because I'm going to scroll down and go off the screen a little bit from where the original question was. We're going to do 2 things. We will show this on a graph, and then we'll look at finding his average rate in meters per minute for this portion of the race. Okay, so if we scroll down here, I'm going to plot distance in meters versus time. So we're relating these two things, distance and time. So let's use the information that's given here. If we're given, hey, after 1.5 minutes, so after a time of 1.5 minutes, he will have gone 300 meters. So I'm going to go up and put a point. I'm going to circle it. That point corresponds to our time of 1.5 minutes, and he's gone 300 meters. Okay, so after 2.8 minutes, he is at 600 meters. So 2.8 is over here. Okay, and I know that because there are 5 spaces in between the 2 and the 3. So our time increments, each block will be 0.2 big. So if this is 2, if we go up by 0.2 increments, 2.8 will be at the, I guess, the 4th line between the 2 and the 3. Okay, so at 2.8 minutes, if we go up to 600 meters, there we'll have our second point, and we're being asked to find, hey, what is the rate, or what is the slope between those 2 points? Okay, so our slope, and sorry, maybe I'll put the coordinates of these 2 points. That's going to be 2.8 and 600, and this point is going to be 1.5 and 300. And what I'm going to do is I'm actually going to use a little bit of math here to do that y2 minus y1 over x2 minus x1 to find our slope. So that's going to be 600, which is our y value for our second point, minus this 300. We're really looking at, hey, how much does it rise going from this point up to this point? So it goes from a y value of 300 up to 600, or a rise of 300 in total. Our run is going to be, hey, we started at 1.5 minutes, we're going to 2.8, so our slope, if we do that math, our numerator will be 300 and our bottom will be 1.3. And I'm going to include units in here because units tell us a lot. So meters per minute, this is still going to be meters per minute, and that's what our question is asking us for, is, hey, what is the rate in meters per minute? So if we do this math, 300 divided by 1.3, we end up with 231 meters every minute. Okay, and that's the slope, or the rate of change for reg. Okay, that should get you ready for trying a few questions from the worksheet that follows. Good luck.